What if I told you that doctors can now take your own immune cells, turn them into superpowered cancer fighters in a lab, and put them back into your body to hunt down and destroy cancer? This isn't science fiction, this is CAR T cell therapy, and it represents one of the most incredible medical breakthroughs of our time. Today, we are diving into a journey that spans nearly 4 decades from experimental bone marrow transplants into a precision engineered cellular weapon. This is a story of how scientists turned an impossible dream into a life saving reality. Let me take you through this remarkable transformation. Let's start our journey in the 1980s. Back then, if you had certain blood cancers like leukemia or lymphoma, your best hope might have been a bone marrow transplant. This was serious business. Doctors would use powerful chemotherapy and radiation to completely wipe out your bone marrow and immune system, then replace it with healthy bone marrow from a donor. Think of it like demolishing your entire house and rebuilding it with someone else's materials. It came with devastating problems. First, finding a perfect donor match was incredibly difficult. Siblings had only 25% chance of being compatible, and finding unrelated donors was like searching for a needle in a haystack. Even worse, when doctors did find a match, these foreign cells often turned against the patient's own healthy tissues, causing a life threatening condition called graft versus host disease. Patients could spend months in isolation, battling infections while their new immune system learned not to attack their own body. But researchers started asking, what if, instead of replacing the entire immune system, we could teach the existing one to fight better? In 1993, scientists achieved something truly groundbreaking. They created the first generation chimeric antigen receptors, or CARs. This was a completely different approach to fighting cancer. Let me explain what this means in simple terms. These elite cancer fighting soldiers can only recognize threats when other immune cells act as scouts, capturing pieces of the enemies and presenting them like a wanted poster. It's a complex process that requires multiple steps, but cars work like giving your T cells high tech night vision goggles and GPS tracking. They allow T cells to directly recognize and bind to specific proteins found on cancer cells, completely bypassing that complicated recognition process. For the first time, scientists could program T cells to target any cancer that displayed the right markers. However, there was a problem. These first generation cars could spot cancer, but they were like soldiers without proper supplies. They would identify the target but then run out of energy before finishing the job. So, throughout the late 1990s and 2000s, scientists went back to the lab. They developed second generation cars by adding co stimulatory domains CD28 and 4-1BB. Think of these as advanced life support systems that provide fuel, communication equipment, and reinforcements. These additions transformed CAR T cells from short lived scouts into persistent, multiplying warriors that could survive and thrive in the hostile environment of a cancer patient's body.
So, here's how modern CAR T therapy works, and it's genuinely fascinating. First, doctors collect your T cells through a process called leukapheresis. Think of it's a sophisticated blood donation where machines separate out just the T cells you need while returning everything else to your body. These precious cells are then shipped in special containers to one of only a handful of specialized laboratories around the world. Here's where the magic happens. Scientists use viral vectors, essentially reprogrammed viruses that can't cause disease, to deliver new genetic instructions directly into your T cell's DNA. It's like updating the software of your phone, except we are updating the targeting system of your immune cells. The lab technicians then grow millions of these newly programmed CAR T cells in carefully controlled conditions. This process takes about 2 to 4 weeks, each cell dividing and multiplying while maintaining its new cancer fighting instructions. Meanwhile, you undergo lymphodepleting chemotherapy, a brief round of treatment that clears space in your immune system. Finally, your personalized CAR T cells return to you through a simple IV infusion. It's look like getting any other IV treatment, but you are receiving millions of your own cells now engineered specifically to hunt down your particular system of cancer. The first successful CAR T treatment was in 2010, but global attention came in 2012 with the case of 6-year-old Emily Whitehead, who had acute lymphoblastic leukemia and no remaining treatment options. Although her CAR T therapy initially caused severe side effects, she eventually Emily stabilized and went into complete remission. More than a decade later, she remains cancer free. Emily's story became a symbol of hope, proving CAR-T's potential even in the most desperate cancer cases. CAR-T therapy represents a breakthrough in cancer treatment, moving from broad, damaging methods to precise reprogramming of immune cells. This innovation has already transformed lives, as seen in patients like Emily Whitehead, and continues to inspire hope for future advances. It shows how science, persistence, and creativity can turn the impossible into reality, making towards progress the foundation for tomorrow's cures.